Hey guys, welcome back to the channel. I have another Marine ECM. This is 8.1 liters, I think, for what I can read on the computer. It's a MEFI 4. I have no other information about the boat or so, but it looks like it's probably a Mercruiser Horizon from what I can see, but I might be wrong. This is 125A4052 MEFI 4, and this is coming from Maryland, 30 Martin. They said they have no communication, no fuel pump, and no spark. So let's see what we have. All right, so I got Diacom ready to go. Let's try to power out the computer. Again, always look into the fuel pump activation as I am doing this. All right. All right, strike one, no fuel pump. That's not a good sign. Strike two, no fiber reference. So far, everything they describe is correct. Let's see if we can connect. This is Diacom trying to connect to the computer, which will be the strike 3. And yes, we have no communication. All right, so everything they describe is 100% correct. This computer is pretty much dead. All right, so I'm going to remove the cover and see what we see inside and see if we can help Terry with this computer. All right, let me open it up and we go from there. All right, got the computer open. I got the Fluke 289 ready for the testing, and I have my information on the screen for me to follow the normal procedures that I do for testing. Just I will tell you what the values should be as I am reading it. So I want to make sure that we have battery voltage, that we have a good 5-volt reference. We have 3.3 volts, 2.8 volts. We have this here, so this is the voltage regulating area. Then we have also this one in here, which converts the 12 volts into an 8-volt supply. And these are for other ICs, not really for the microprocessor, obviously. This one is the one that's in charge of the 2.8, and we have 2.8, 5 volts, and 3.3 here. So this is where I want to focus myself, and then check the microprocessor to see if it has the 5.3 and the 5 volts and the 3.3 in there. I turned the lamp off, trying to make it a little friendly for you, not that friendly for me. Okay, let me change this color of the light, see if I see anything more. Can change the light color. Hopefully that is, I mean, is still reflection in there. All right, so let's look for the 13 volt first. All right, so battery voltage, I'm gonna have to switch my hands. I'm trying to give you the best possible results, and I have to be very careful here while I'm doing this because it is live. So we got 13 volts in there. These should read around 6.3 and then 12 volts in here. So we got the 12 volts in there. And let's see if we got the 6.3 here. And yes, we do. All right, so we got another 13 volts in here. And we do have that. Let's check for the 5 volt reference. So we should have 5 volts in here. And we do have that one. Let's check for a 3.3. She's right in the middle of these two. Okay, we have a problem in here. This should be 3.3 volts. So this is the 3.3 area. Let me zoom into that. So we should have 3.3 volts in here. If the 3.3 is not there, it's more likely that we're going to have over 3.3 volts in the microprocessor. So let's check that. Yes, so this should be 3.3. Let me show you the outside. I'm touching right now. Let me get into a better spot. So that's the 5 volts. That's the outside. Sometimes a little hard to do, but the outside ring, the center is a ground, and then the bottom, it should be 3.3 volts. But we're getting 5.5 A6. So this is definitely too much for the microprocessor. The microprocessor cannot start. These are the two main voltage rails for the microprocessor to work. All right, so let me check the 2.8 volt, which is under layer. So the outer rings in the microprocessor are only for 5 volts and 3.3, but there is also a 2.8 volt, which I can check pretty easy right here. So let's see what we got here. One side is, oh yeah, so we got 5 volts in there as well. So we definitely see that we're missing now two voltage rails, and that is microprocessor. So this is not looking too good because the one that brings or steps down that voltage is this regulator. I've seen this many times happening on these MEFI 4s and MEFI 3s when voltage of 12 volts gets injected into one of the sensors. Because let's say, the 5 volt reference on most of the computers are protected to short to ground. Because like they know, let's say the manufacturer know that, you're supplying 5 volts to the sensor, a ground, and then the signal. Let's say, the sensor can get shorted and it can get pulled to ground. But they don't protect the circuitry for a short to power, which is, all style. These are 2004-5. I mean, they should have done better. Um, but as you see, there is absolutely no diodes to protect that in here. And then if battery voltage, a wire gets corroded and or burned and now touches a 12 volts, it touches a 5 volt reference, it damages the voltage regulator. Again, this is still too soon to condemn a computer. I still got to do my test, but definitely we see what we see here. So we have definitely a computer that is not powering up. We're missing, or we have the incorrect voltage rails across the board. I need to now stop the video because this is a little more intricate and dangerous for me to be recording a video while I'm doing the test. I need to get a sharper needle test, and this is the one I use. Let me just show you the comparison to one and another. So this is a little sometimes to show, but yeah, it's a sharper, less intrusive for the gel and less dangerous for me to touch other components, but because as you can see here, it's definitely really populated. So I want to focus myself into what I'm doing in here to give him the correct result and see if we can repair on now this computer. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye-bye.